So we're now up here on the cliffs at Flamborough Head, around 10 metres above the high tide mark. But the cliffs here are still being eroded by processes that take place above the waterline.
And we call these subaerial processes because they happen literally below the air or atmosphere. And these are just as important as marine processes in changing the shape of our coastline.
So we're now going to go and take a look at these processes up close on the cliffs.
Mechanical weathering processes happen in this area here, and that's what makes these huge cliffs turn into these tiny little fragments. And this happens through two main processes. Frost cracking, also known as freeze-thaw weathering, is when ice crystals get into the cracks in the rock. They expand and cause the rock to flake away and shatter. The same process also happens with salt crystals, and that's called salt cracking. Mechanical weathering can also be driven biologically. When roots and trees grow into fractures in the rock, over time they can cause these cracks to expand. The roots also anchor the plants against the force of the wind. And this force can be transferred back into the cliff face, making the cliff weaker over time. And we can see this here where the plant is actually growing straight out of one of the cracks in the cliff face.
Chemical weathering also takes place, which involves the solution and chemical breakdown of rock minerals. This is helped by the fact that rainwater and spray from the sea is slightly acidic. In chalk and limestone rocks like this, that acid reacts with calcium carbonate. It forms a precipitate substance that can then be soluble in water and gets washed away. So rocks like this become loosened over time. Look at this, big landslide there. See, there's some slumping and there's a bit of an earth flow as well. Let's go around to the other side and we'll have a look at it. Yeah, stay back from that edge, I think. All these weathering processes weaken and break down the rock mass. And one dramatic consequence of subaerial weathering can be a phenomenon that I've spent many years studying, mass movements or landslides. These occur when the rock becomes so weak that it collapses. And landslides typically occur following heavy rainfall when the ground is saturated and there are very high water pressures that force fragments of the rock and soil apart, causing the slope to collapse. Now, looking across the bay, in these hard chalk cliffs, we typically see mass movements there occurring in the form of rock falls. And we see evidence for that with all the rocks of different sizes or talus deposited at the base of the cliffs. But here, slightly to the south on Flamborough Head, the chalk is actually disappearing away underground, and it's overlain by this soft, younger material called boulder clay or glacial till. This material was only deposited in the last ice age, which ended only around 12,000 years ago. In this muddy mix of boulders and clay materials, we see landslides occurring through rotational slumping. This is where the failure occurs along a semicircular zone, and we see rotational landslide scars like these forming. In some places, we also see terrace cliff profiles where the ground has slipped but not completely failed. Mass movements like this deliver sediment down onto the foreshore, where it is then broken up and removed by marine processes, and that's what we're going to look at next.